and do that. That's it. And fans are very low torque application. Hey guys, I'm pissed. I'm livid. What the hell is this sorry excuse for a tool? But before I get to the reasons why, welcome to the channel. Today I have the Ryobi workbench blower, and in this video I will be tearing it down and analyzing its design and build quality from a product engineering perspective. But before I get to all that, I have to go on a little rant here. This thing is absolutely pointless in my humble yet infallible opinion. It's intended to clean off workbenches of dust, shavings, and other debris. Now, hey, if you've got the, let's see, how much is it? $55 plus that doesn't include the battery. The battery's another $50 to $60. So if you got the spare $110 laying around that you are perfectly happy just throwing right down the drain, then be my guest. But hear me out first. Now, go with me here. This might be a revolutionary idea, I'm not sure. But this little $3 item might be a better solution. Dun, 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 dun. Maybe. I don't know. Maybe I'm just crazy. I'm not sure who has enough workbench area that it would take too much time to dust off with a hand brush. But I don't know, maybe I'm missing something. This is basically a mini leaf blower. It's same exact concept as a leaf blower, probably a centrifugal impeller in there. So I don't know too many workbenches that don't have 110 outlet. So why wouldn't you just use a leaf blower if you really feel the need to clean off your work area using the tornado method, which I don't know is the best method to begin with, then use a leaf blower. They're $30. It'll be a dual purpose, and so you save yourself. It's 3 times less cost, and it's definitely has a lot more power. This had, even on the third setting, it's not really much. You're not really gonna move much with it. So you get more power for a third of the price. Just use a leaf blower if you're hell bent on cleaning off your bench this way. Or now this might be the most another revolutionary alternative. There's this thing called a shop vac, and that most of them have a reversing feature on them that will blow through the suction tube instead of suck. And let's be honest, if you don't have a shop vac, I don't know what you're doing with your life. Like, if you have tools and a workbench and you don't have a shop vac, you're doing it wrong. And then my last alternative, and again, this is probably the most controversial, revolutionary alternative to this useless product. Use the shop vac for its intended purpose and just clean the shavings or the debris off of your shelf to begin with, and then not have to sweep them off the floor. So I really don't get like what niche this is meant for. Now, maybe I'm missing something. Maybe like remote job sites, or people. A lot of people work out of their truck and they don't have access to 110 outlet. Again, I would recommend the Debris Remover 3000. As seen on TV. Registered trademark, patent pending. Maybe it's just me. I don't know. So I just had to vent a little bit and pray that I'm missing some reasonable application for this ridiculous item. If you know one of them, go ahead and call me out in the comments below. But I'm 100% sure that no one will have a reasonable application for this, because I'm never wrong. So if that's not a call out, then I don't know what is. All right, so let's get into this thing more detail and actually see. So I think the application for this is ridiculous. But that being said, is the build quality good, and for that intended ridiculous purpose, is it still good quality? So let's get to it. So first off, on the outside, I can see that this is a thermoplastic elastomer, and which is that's the properties I would want out of a nozzle. Something flexible that I could get into crevices with and bend around, and it's not gonna crack and abrade. And it's probably this could be thermoformed. You can see the lines where the tool halves came together, the mold halves came together. And thermoforming would probably be better than an injection mold, where you'd have to have slides come in here to make these holds. So either a pressure or vacuum thermoform, you have a pre-existing tube that gets heated up, and then two halves of the mold come together around it, and then air pressure is put inside the tube before it's cut off, and make it conform to this slightly organic shape. That's what I'm guessing the manufacturing process is here. Yeah, so the material properties of this part are good, for what the nozzle is meant for, but it's not good to retain it to here, because rubber is soft and these are tiny little features. So they put a plastic ring in it to give hard plastic properties where you need hard plastic properties, and soft elastic properties where you need soft elastic properties. So it's pretty similar to what you would find on a drill, over-molded, bi-injection molded, thermoplastic elastomer over hard thermoplastic. Some gloss, alternating gloss texture purely for aesthetic purposes. There's no texture there. You can see how cheap and plasticky that looks. So that's why most products of any quality are textured, just to make them look less cheap. But it's the battery that doesn't come with it. There's the specs the deets if you wanted to know. And got good grip to it. Not too bad. Yeah, so all right, let's get into it. See what we can figure out. So first off, simple injection molded piece. A half of the mold, B half of the mold. This is the cavity. This is the core side of the mold. The core side comes in and makes these internal features. Cavity comes in and makes the outer shell. Pretty simple. And you see if you can see right there, it says ABS. There you go. ABS, which is not typical for a handheld tool. Most of the handheld tools I've reviewed so far were some type of nylon blend with glass. That is a pretty high strength engineering plastic, glass filled nylon, and this is more of a consumer plastic. But that being said, it's not a low quality plastic. ABS molds really, really well. It's highly colorable. It's highly dimensionally stable. So when it comes out of the mold, it's going to be perfectly flat. Whereas nylon will have a tendency to want to warp and cool unevenly as opposed to evenly. So ABS is amorphous, and that's the main difference. Nylon is crystalline structure in the polymeric structure, and ABS is amorphous, and amorphous just means it's consistent all throughout the polymer, and so it does very predictable things. But that being said, it's not as strong, so it's not as stiff and it's not as strong. So they're obviously not intending this to be a high impact, high load tool, like an impact driver or a drill that might get dropped and banged around and subject to the loads of a drivetrain or something. The only loads that this thing has to take is it just has to hold on to this motor and do that. That's it. And fans are very low torque application. They're typically high RPM but low torque. So there really isn't a whole lot of external loads that this should see outside of being accidentally dropped. Okay, so, and this is a centrifugal fan design, much like you would find in jacuzzi pumps or pool pumps, but for water. And this one has the blades closer together, which is typical of ones meant for a low density working fluid like air is. So yeah, that's pretty it is pretty cool that you can make geometry that complex with just an injection molded part. All right, it's got the material called out. So this is made out of the same material that most hard plastic housings of drills and impact drivers are made out of. Nylon 6, which is the less common version of nylon that's more colorable. Not sure why they would use nylon 6 here instead of nylon 6.6. This part isn't intended to be seen, so it could be as ugly, and as you know, the glass particles will migrate to the surface more on not traditional 6.6. So not really sure why they cared to use nylon 6. It might just be they had some of it. They use it in more other parts that they make at the same factory, and so they just ended up using the same polymer. It's probably but either one are probably overkill for this application. But so you can see the little circles, those are ejector pins. So one half of the mold comes in and makes this geometry, and then one half comes in and makes this flat and has little features to make those. So really good ribbing design there. You can tell that's going to be stiff. This thing was really over-engineered, probably, for how little. This is probably making a couple of psi. It's really not doing a lot of work. So these blades are probably much thicker than they had to be, and the overall safety factor of this part is probably a lot higher than it needs to be. You saw that I struggled a little bit to get it off, which is good with something has this high of a RPM. That was a good stout tight fit on there, which is not always easy to do with injection molded parts. A lot of times, they'll come out too tight or too loose, just variation from batch to batch and part to part. So you don't want something that's going to be spinning at 5,000 RPM to have any play in it, and that's good. It definitely did not. And also draft parts have to have draft that are injection molded, and this metal coupler doesn't have any draft. It's just flat all the way down, and so they went on this particular area. It looks like they either went with no draft or possibly a post process to get that to be nice and stiff on there. But it has a really nice feel to it, exactly how I would want something to feel that was going to be turning that fast. So okay, we got the other piece here. Says ABS also. Same story. Nothing new. That's pretty good size motor in there. Let's see if I can. All right. So this is nice. So this spinning 5,000 RPM. It would probably gonna make some vibrations for the user. This rubber here is not all that soft, and it's also not all that thick. I can feel the hard plastic on the back side of it. It's really not gonna prevent any vibration. So they added, these probably, again, thermoplastic elastomers, good and cheap, easy way to make a product feel well made. Is even if this is a cheap motor that isn't balanced properly, it can be the bare bones low end bottom shelf motor, but you put these rubber isolators on it and all of a sudden it feels like it's a high end motor that's well balanced. And but so as far as the motor construction itself, nothing really to talk about here. It's definitely a traditional brushed motor, and it looks like same design you might find in an RC car 20, 30 years ago. Nothing special. So, all right, well, let's get to, I think these are the last parts here, and these are a different size. If you wanted to know, the first screws were a T20, and these are a T15. Yeah, see little bits of plastic falling off because these are looks like they're thread cutting screws a little bit to cut into the plastic, so some of that's falling off. Let's see. Okay, so again, similar to drills and impact drivers, you can see the bi-injection molding features. They've got dovetails to hold that soft elastomer on there, and holes strategically placed as undercut rivet style to let the material go through the plastic, and then with a little cap on it, undercut shoulder so that it's hard to fall off. Yep, and this is the same material, which is what you would expect, same exact color. Let's see, can you see that? It says, there we go, yep. ABS plus TPE. So similar to the Hercules, they're not specifying exactly what thermoplastic elastomer this is. They're just saying generically it's TPE. So yeah, and that's there's been some good ribbing, good structural ribbing in here to make that good and stiff. You can really overcome if the deficiency of a material by just adding more ribs. So say nylon 666 has a Young's modulus, which is the modulus of elasticity, how stiff a material is. Say glass-filled nylon has a Young's modulus of like 300,000, and ABS only has a Young's modulus of like 150,000. Well, so that's half the stiffness. Well, you just add double the ribs, and you basically get to a bulk part that is, for all intents and purposes, as stiff as the other material. So on a nylon 6 or glass-filled nylon 6 part, probably wouldn't even need these ribs here, especially for something meant to be this duty. It's not an impact driver, it's just a fan. It's a glorified fan, a pointless glorified fan. So pretty good wire routing here. That's actually better than I'm used to seeing on a lot of other tools. They actually have them separated as opposed to just all kind of in a bunch going together. It's pretty simple, just electrical contacts over molded. See that? I don't know if you can see that undercut in there. I'm pretty sure that these contacts are put into the mold, and then that nylon or whatever that is injected over this piece, so it's a single piece. Yeah, it looks like this is a big heat sink for the driver that's in here. Again, it's just a brush motor, so the driver doesn't have to be very complicated, but anytime a bunch of power is routing through a bottleneck, it's a good idea to have a heat sink. So, not sure if that's a fuse or a capacitor or what that is, but yeah. All right, well, I think I've pretty much exhausted all the details on this. Again, in my opinion, which has to be correct, a useless item, but if you got the money to throw around, feel free. If you got any questions that I didn't answer about it, throw them in the comments below. I think this is This is what it's intended to be, and there weren't really a whole lot of specs to call out, except that it's 18 volt, 160 miles per hour, and 3-speed modes. Yeah, there's really not a whole lot to it. It blows. That's my summary for this. It blows. But if you like this video, you like this type of analysis of products and tools, hit that like button down below. And if you want to see these videos, more of these videos, I upload them between one every 1 to 2 weeks. So if you want to see more of those, hit that subscribe button and hit the little bell icon next to it so that you receive email notifications for those new episodes. Yeah, hope you guys enjoyed it, and I will see y'all next time.